All right, so section 6.1 continued. We did 6.1a already, so this is going to be the continuation of it. This is going to be factoring something other than the GCF. Okay? So let's talk about the distributive property. Remember the distributive property? We multiply across addition or subtraction. This is 5 times x, which we know we can just smush. And then we have 5 times 4, which is 20. So this is what's called the distributive property, or the distributive property of multiplication across addition or subtraction. That's its, its full, name on its birth certificate. Well, sometimes we can factor out a common monomial term by reversing the distributive property. Okay? So we're going to talk about this whole factoring out something, which, remember I said, was the opposite of the distributive property. Okay. So if I were to work backwards from this, I've got this 5x plus 20. What is the greatest common factor of 5x and 20? So that was the stuff we were doing in 6.1a. I'm sorry, this is so janky here. This is not my normal setup, so that's why this is kind of crooked and wobbly and stuff, so I apologize for all this. So the greatest common factor of these two is 5. Remember, there's not an x common, so I can't, that's not part of the greatest common factor. So what I can do is I can factor out that greatest common factor, which the greatest common factor of these two is 5. Now, when I say factor out, or sometimes you might say take out a 5, it means you're dividing by 5. So if I divide this by 5, I get 1x. If I divide 20 by 5, I get 4. Now, really, all that division tends to be a lot more complicated to think about. It's usually easier if you just think of it as the opposite of the distributive property, because a lot of students are really comfortable with the distributive property. So, you're really comfortable with that multiplication, right? So it might be easier to think of it as 5 times what will give you 5x, and 5 times what will give you 20. So that might be an easier way to think of it. So to start our factoring, I'm going to give you the start of it. Okay. So this is going to be a little tricky here. I try to write this out so that my videos aren't, 7 hours long of me droning on and on here. So complete the factoring. 3x minus 21 equals 3 times what? So I've already taken out the 3, the GCF. So I took out the 3 for you. So what do I need to put here in parentheses to distribute the 3 to in order to get this? So 3 times what will give you 3x? Well, that's going to have to be an x here. And then 3 times what will give me 21? That's going to be 7. Okay. Now, I don't know if it's easier for you guys to think of it as division or multiplication. That's just going to depend on how your brain works. But it is a division process because it's the opposite of distributing. Distributing is a multiplicative process. So factoring is a division process. So if I divide by 3, 3x divided by 3, I get x. 21 divided by 3, I get 7. And then notice that sign right there stays the same. So this pink part would be what you would fill in as your answer. Okay, let's see here. So this one, 6y cubed plus 24y squared. It's kind of hard to tell those are y's. I took out the greatest common factor for you already. It's 6y squared. Right? The greatest common factor of 6 and 24 is 6. The greatest common factor of y cubed and y squared is the smaller of the two exponents. It's a y squared. And that's kind of hard to tell that's a y because my little tail's down there. So we got to figure out what's going to go in these parentheses so that when I redistribute, I get this expression. So this process is called factoring. So 6y squared times what is going to give you 6y cubed? Well, what's missing here? Well, this is a y cubed, that's a y squared, so how many more y's do I need? Right, I just need one more y here. So I need a y here. And then 24y squared. Well, 6 times what's going to give me 24? That's going to be a 4. Y squared, I've already got a y squared out here, so I don't need another y here. So I end up with 6y squared on the outside, and then y plus 4 on the inside. Notice when I redistribute to check it, 6y squared times y is 6y cubed. 6y squared times 4 is 24y squared. You can think of it in terms of division. Hawks focuses on the division, or you can think of it in terms of multiplication of the distributive property. You know, what do I need to multiply by to get this stuff? And this is going to utilize those exponent laws that I'm hoping by now that you're a little more comfortable with. You know, like that a y squared times a y is a y to the third, because that's a second power plus a first power. 2 plus 1 is 3. Okay. This one's a little more menacing because there's 3 terms to it. So looking at these 3 terms here, the greatest common factor of these 3 terms, well, let's look at the numerical part, 15, 20, and 5. The greatest common factor of those 3 numbers, the largest number that goes into 15, 20, and 5 is 5. The greatest common factor of x, x squared, and x is the smallest of the exponents. Well, that's an x to the first. We got a y squared, a y to the first, and a y to the first. Smaller of the exponents is y to the first. So this was already given to you, but I just wanted to show you because eventually we're going to have to find that ourselves. We're going to have to find that greatest common factor ourselves. So if that's the greatest common factor, now we got to figure out what 3 terms are going to go into these parentheses, this parenthesis here, to give us this answer when we redistribute. That sounded really awkward. So we need to think about 5xy times what will give me 15xy squared. So let's just look at what's missing. So 5, we need to get to 15. So what do we need? What number needs to go here? We need a 3. X, well, I've already got an x, so I don't need another one. Y squared, I've got a y to the first, so I need one more y in here. So far for this first term, I need a 3 and I need a y, so that when I multiply that first product there, I get this 15xy squared. All right, let's look at the 20. I'm going to put a minus in here because that sign right there. 20x squared y. All right, so that middle number, I need a 4, right? Because I need 5 times what's going to give me 20. All right, x squared. I've got 1x, so I need another one out here to give me the squared. Y. I've already got a y. Don't put another one because then you'll get a y squared, and you don't want that. And then lastly, all right, 5. Well, I've already got a 5. So what do I have to multiply by 5 by to get 5? This one's kind of tricky. 5 times what will give me 5? Well, that's going to be a 1. I don't need another x, because x, I don't want another one because I've already got that x. I don't need another y because I've already got that y. So this last term here is just going to be a 1. So watch when I redistribute here. 5xy times 3y. That's 15xy squared. Right there. 5xy times 4x. That's going to be a 20x squared y. Now this one you may say, oh, well, when I take this out, it's gone. Well, it's not really gone. You still gotta have a placeholder there, because if you don't have this plus 1, if you just have those 2 terms in your answer, then you never get this 5xy. So you do need a 1 right here. That's necessary. Hawks is all about the unnecessary ones, but no, that's a necessary one. So 5xy times 1 is just going to be 5xy. So this is the reverse of the distributive property. This factoring is the opposite of the distributive property, and you can use the distributive property to check your answers. Heck, you can even use the distributive property to help find your answers. Thinking about what do I have to multiply by to get, this. All right, so the next one, scooch this up a little bit here. We're going to factor out the greatest common factor, and Hawks will tell you, or it's negative. Boy, I'll tell you about that one when we get there. Let me scooch this over so you can't see that. So I'll show you what it means by those negatives here. Don't look at the answer, look away. Okay, so we got this 4x cubed plus 8x. These are very similar to the ones I just did. I'm just not going to give you that starting point, of that greatest common factor. It's already outside the parentheses. So we're going to have to find the greatest common factor first. So what is the greatest common factor of these two terms? Well, what's the greatest common factor of 4 and 8? What's the largest number that both 4 and 8 divide in? Or what's the largest number, that goes into 4 and 8 without a remainder? Well, 2 goes into both of them, but there's something bigger. It's not 8, because 8 doesn't divide into 4. So it's going to be 4 that goes into both of these. Looking at x to the third and x, the smaller of the exponents is that x to the first. Okay, so there's my greatest common factor of 4x. Now, I'm going to have parentheses right here. So 4x times what is going to give me 4x cubed? Well, I've already got the 4 there, so I just need an x cubed. I have that x to the 1, so what needs to go here so that I'll multiply 4x times this and get 4x cubed? Well, it looks like I need, I have that x to the 1, I need 2 more x's, right? So I need an x squared. I got that plus. What do I need to multiply 4x by to give me 8x? Well, I've already got the x there, so I just need something to multiply by 4 to give me 8. Now remember, you can check your answers with the distributive property. So 4x times x squared is 4x cubed. 4x times 2 is 8x. So this process is called factoring, and we're factoring out this monomial factor here. All right, so let's do another one here. I got just a few more for this part. Man, this thing is all kinds of wobbly and janky. It won't stay straight. So yeah, I'm sorry about that. What's the greatest common factor of 3x squared y squared and 6xy squared? Well, the greatest common factor of 3 and 6 is 3. The greatest common factor of x squared and x is just x. Remember, it's the smaller of the exponents. The greatest common factor of y squared and y squared is y squared, because it's the smaller of the exponents. Well, they're the same, so smaller is same one. All right, so we got 3xy squared. Parentheses. Now what's going to go in these parentheses? What do I have to multiply 3xy squared by to get 3x squared y squared? All right, well, the 3's already there, so I don't have to worry about coefficient. The x times something needs to give me x squared, so I'm going to need another x there. Y squared times what's going to give you y squared? I don't need any more y's, so it looks like all I need is just an x. So I'm taking the approach of looking at this in terms of multiplication. If you want to do this in terms of division, you can take this term and divide it by this. You can take this 3x squared y squared and divide it by 3xy squared and simplify that expression. I think that's a little more convoluted and stuff. That's in my opinion. And I don't just mean like for me personally. I mean like historically for students, that they don't tend to like that. That technique is a little bit more awkward. So we're going to put that minus there. Now what do I have to multiply 3xy squared by to get this term? Well, I need a 6. So 3 times what's going to give me 6? That's going to be a 2. All right, x. Oh, there it is. y squared. Oh, there's already a y squared, so I don't need any variable part to this. So I just need that 2. Here I needed an x because I had an x out here and I wanted it to be a squared. So I needed another one. You can check your answer by the distributive property. All right. This one's a little bit bigger, but this is a good opportunity to pause the video and see if you can find the greatest common factor for these 3 terms. Try to find the greatest common factor, and then maybe go ahead and try to factor it as well. So looking at this, the greatest common factor of 2, 14, and 26 is going to be 2. It's the largest number that will divide into 2, 14, and 26. The greatest common factor for the variables, we have an x squared, and an x. Smallest power is going to be that 1, that x to the 1. Y squared, y, and y. Smallest exponent is going to be, again, 1. So my greatest common factor of these 3 terms is 2xy. We got the parenthesis there. Now we got to figure out what to multiply 2xy by to get 2xy squared. Well, we've already got the 2. We've already got the x. So this is a y. I want it to be a y squared. So what needs to be right here so that when I multiply this, I go from a y to a y squared. Yep, we need a y. There's a plus right there. All right, 2 times what's going to give me 14? 7. Okay, x times something's got to give me x squared. Ooh, another x. And then y, I've already got one, so I don't need another y. There's my minus. 2 times what's going to give me 26? It's going to be 13. X, already there. Y, already there. So I don't need any more variables. Always check your answer by using the distributive property. You'll multiply this out and see if you get this expression. All right. So this one's actually a little bit easier. This next one is more along the lines of the stuff that you're going to see more often. Now, we see a few of these nastier ones, but a lot of this chapter, we're going to be seeing a lot of just this kind of stuff. So what's the greatest common factor of 5x squared, 15x, and 5? Well, 5, 15, 5. What's the greatest common factor of those? It's not 15, because remember 15 does not go into 5, but 5 goes into 15. So my greatest common factor is 5. Let's look at the variables though. We have an x squared, an x, and then no variable. So what's the greatest common factor for those variables? Now you may say it's x because, well, the smallest exponent is x to the 1. No, remember there's no x right here. So it's the greatest common, the greatest shared factor. So there's no x right here. So the only thing that's shared by these 3 terms is just that 5. Then when I factor out that 5, I'm going to get x squared, because that multiplies to be 5x squared, minus, so what's going to go right here in the middle? Well, I need a 3, so that 5 times 3 is 15, and then I'm going to need an x here, because I don't have one out here. And then lastly, 5 times what is going to give me 5? It's going to be a 1. So that one's kind of tricky, because there's an x that's common to 2 of these, but it's not common to all 3. So I can't factor out an x from this last term because there's not one there. You could think of it as an x to the 0 if you wanted to, and that's the smallest exponent. But just mainly focus on the common part. All right, so last one for this part of 6.1. Remember 6.1 split up into 6.1a, b, and c in Hawks. So this is going to finish up part B. So again, we got 3 terms. I got a negative 3x squared minus 6x cubed y plus 9x. This one's going to be more challenging because in Hawks, if you see a negative for your first term here, it's going to want you to factor out that negative. it's going to want that to be part of your greatest common factor. I know typically with the greatest common factor, we think of it in terms of positive numbers. But for these, if you have a negative out front here, you're going to need to pull out a negative. So let's just know we're going to have to, take that negative out. So let's look at the 3, 6, and 9. What's the greatest common factor of 3, 6, and 9? Well, it's going to be 3. So far we've got the negative. There it is right there. And then we got the 3. Now, what's the greatest common factor for the x's? I got an x squared, I got an x cubed, and I got an x to the first. They all three have an x term. The smallest exponent of the 3 is that 1. Let's look at the y's. I don't have a y here. I got a y to the first. I don't have a y here. So I can't take out a y because it's not shared. I don't have a y in every single term. If I had a y in every term, then I would pick the smallest exponent of those. So my GCF is just this negative 3x. All right, here's my parentheses. What do I have to multiply negative 3 by to get negative 3? Just positive 1. What do I have to multiply x by to get x squared? Another x. So it would just be 1, positive 1, x. Now, in Hawks, you don't have to write that 1 right there. But if you put it there, it's not wrong. But just remember when you put your answer into Hawks, not to put that 1 there. Okay. Now, normally we would just put a minus right here, right? We just carry that sign over. But because we took out that negative, that's going to change things. Negative 3 times what number here is going to give me negative 6? Well, negative 3 times positive 2 is going to give me that negative 6. All right, so I need an x cubed. So that'll be x. I'm going to need x squared right here to give me that x cubed. I need to multiply and I need to bring in a y because I don't have one out here. So whoop, there's a y. Okay, and then lastly, the 9x. So negative 3 times what will give me positive 9? That's going to have to be a negative 3. And then the x is already out there. So notice when I redistribute, I get negative 3x times x is negative 3x squared. Negative 3x times positive 2 is negative 6. Those two x's right there, x times x squared is x cubed. And there's the y. Negative 3x times negative 3 is a positive 9x. All right, so this one finishes up 6.1b. We have one more part of 6.1. I know this is a very long section. So the next part is going to be 6.1c.